This is Algebra 2, Section 10.3, the unit circle. And we'll be forging into new territory here. Our objectives are going to be to convert angle measures between degrees and radians and back and forth, find values of trig functions on a unit circle, and also we will be working with arc length as well. Why is Miss Radian such a good reporter? Well, why would that be? Let's see. Anyone have a guess? She covers the story from every angle. She does a good job, in other words. Okay, so as we saw on the paper plate activity, we defined a radian, which is the measure of the angle that's formed when the arc length has a length of 1 radius. So the measure of the angle formed when the arc length of that angle measures 1 radius. And we saw on the paper plate it's around 57 degrees. A radian is always around, it's 57 point something. So like if this was my radius, and if I took that length and came out here, it'd be about that far. That's 1 radian. We also learned on our paper plate activity that if we go all the way around the circle, that's 2 pi, which is the same as 360 degrees. Therefore, pi would just be half of that, 180 degrees. And we'll be using, my favorite conversion is to use pi equals 180 because it's already reduced. Our book seems to use the 2 pi equals 360, which I think is ridiculous. So I'm going to be using pi equals 180. And I like dimensional analysis, so that's what I'm going to use as well. We're going to be converting these, so negative 60 degrees is my starting one. I'm going to just go ahead and draw my dimensional analysis bars. You can put the 1 down there if you want. And we're converting degrees, so that means I need degrees down here. I'm going to use 180 degrees equals pi. And then on this one, we are going to leave it as a fraction because we can. And it will be negative, so it's going to be negative. And then 60 goes into 60 once, and it goes into 180 3 times. So you end up with negative pi over 3. Please write it as a reduced fraction, because that's how we do it. It's conventional. As you can see here, it's written as a reduced fraction. So on 2 pi over 3, the division bar, I'll just extend it out, and that'll become the bar in my dimensional analysis. So I've got 2 pi over 3. And I'm converting radians, the pi, so down here I'm going to need the pi, and up here the 180. So the pi's are going to cancel out, and I can actually do some of this in my head because 3, again, will go into 180, 60 times. And then 2 times 60 is 120, 120 degrees. If you are given an angle, like say it says theta equals 5.2. That is not 5.2 degrees. That's 5.2 radians. So if there's it doesn't say radians there, but if it's understood to be radians. So we don't really put the rads in, but you can if you wanted to. Okay, these are for you to try on your own. So you can pause, and then I will be giving the answers. Okay, so this is going to be 180 degrees to pi, and that simplifies very nicely. Oh, no, it doesn't. My bad. Actually, that will divide by... What can we divide that by? 2... Oh, 10, of course. Silly me. Okay, 8 and 18. Oh, that'll divide some more. So by 2... So we end up with 4 pi on top and 9 on bottom. 4 pi over 9. And then on this one, 2 pi over 9. I'll extend this out. I know the pi goes there, the 180 up here. Those are going to cancel. 9 goes in there once. 9 will go in there 20 times. 2 times 20 is 40 degrees. Okay, a couple more, check it out. So you can pause, and then I'll be giving the answers. 180 degrees equals pi. Oh, let's see. We could put 6 into there. 6 goes into 18, 180 30 times. And that's going to reduce down again to 5. So I'm going to have that negative out front, negative pi over 5. And then 4 pi rads. Pi 180. Cancel, cancel. And let's see, what's 4 times 180? I might have it here in my notebook. Let me check. Or probably that time you could have just done it on your calculator. Yeah, I don't know what that is. 4 times 180. 720. I probably should have known that, huh? Oh, the unit circle. Sorry this thing is in the way. It's really annoying. Put it down there. So we've already talked about this too with our paper plate, and in class I'm going to give you this unit circle blank, and so you or we in class will fill this all out. And you already know about all these angles because we did them in class with the paper plate, and we'll go ahead and we'll fill all these in. Keep in mind that sine is y over r. It is also, on the unit circle, it's just the y value. Cosine is just the x value. Tan is y over x. So those are some things to keep in mind. Oh, the unit circle for quadrantial angles. So that's going to be the angles on the quadrants. 0, 360 here, 90, 180, 270. Or in their radian, that would be 2 pi, pi over 2, pi, 3 pi over 2. So on the unit circle, if you think about this being a circle here, I'll just draw. That's pretty bad. Pretend that's really sad. Pretend this is 1 unit. So if you were plotting this point, you'd be going over 1 and up and down 0. This point would be back and forth 0, up 1. This would be back 1, up and down 0. And this is back and forth 0 and down 1. Those are really easy to remember, right? You can visualize those in your head. So you can find the sine, cosine, tan, and cosecant, secant, cotan of these quadrantial angles just by thinking about these points, which you can easily do in your head. So like if you wanted to do tan of pi, well, we know tan is y over x on the unit circle. So, oh gee, the phone is ringing. I'll just have to let it ring. Tan of pi is going to be, so y is going to be the 0 over the negative 1. And that's just 0. And then, too bad they're ringing me, huh? Let's try just one more. How about, let's do cosecant just for fun of pi over 2. So cosecant is 1 over sine of pi over 2, and sine is the y value. So, or you could just do sine of pi over 2, do the reciprocal. I guess I'll just do it that way. Sine of pi over 2 is here. Sine is the y value, that's 1. And so cosecant of pi over 2 is also 1. Use the unit circle to find the exact value of each trig function. In class, I'm also going to show you the hand trick because you can use it. You could do that, find this using your hand. You don't even really need to memorize the unit circle. But since I can't show you that on this video, oh dear, they're ringing me again. Tell you what I'll do. I'll pause this tape and then I'll just have to do another part.